Okay, here's a Sound Simulator Unit 2 from a Sharpshooter that's wired up, ready to be tested. We have over here just a standard power brick for an external disk drive that's plugged in to these connectors here that provides +5 and +12 volts for the board to operate it on the bench. That's all you need. You see down here we have the black lead, which is ground, which is connected to pins 1 and 2 on J1. The red lead, which is the +5 volts, which is connected to pin 3 on J1. And then the yellow lead, which is +12 volts, which is connected to pin 9 on J1. And the actual pin numbers are marked on the solder side of the board. This is a single-sided board, so you see there are no traces on this side of the board, but they're actually marked on the other side. We also have here this is a bypass cap for the input power, but I have a wire here hooked up to the ground side, and we're going to use this for testing the sounds in a little bit. So you need a jumper wire for that. And then lastly, we have the speaker, which is just hooked up to pins 1 and 9 on J2. I had to replace the connector pins on this board because one was broken and one was set was badly corroded, as is typical for these game plan .100 pins. So now everything's all set, and all I have to do is plug in the power supply. When you first plug in or power up these boards, they make a lot of noise. This way you know that the board is operating. If it's in the machine and it doesn't make a lot of noise, when you turn it on, you have a problem somewhere in the sound system. Since we're here on the bench and all we have is power and a speaker that we know works, it should make a lot of noise when we fire it up. So plug in the power, and now you know you've got at least the output part of the soundboard is working. Now if you power it up and you don't get any sound, the thing that you need to first check is, in addition to the connector, if you're unsure about that, is to touch the volume control pot with your finger. And you should get a buzzing on the speaker. If you don't get a buzzing on the speaker, you have to suspect that you have a problem either with the volume control pot itself, or with one or both of the amplifier chips here, LM380, or with this non-polarized cap that's on the output as well. So this is basically the output part of the circuit of the board that goes to the speaker. And if you're not getting any sounds when you power the board up, those are the things that you need to check first. So, given the fact that this board is architected with 3 different sound generator chips, the chances of all 3 being bad, or all 3 of those circuits being bad, are really slim, and you should be able to get some type of sound when you power the board on. So if you've gotten this far and you know that the speaker's working and the amplifier circuit is working, this is now when we're going to conduct the tests of each of the sounds and the input to the boards and the output, which is the actual sounds. The 3 different sound generator chips on this board deal with different sounds. This chip up here and this row of transistors, resistors, and capacitors create all the chime sounds. This chip here in the middle is the one that is responsible for all of the sound effect sounds, and that includes the gun, the snake, the horse, the howl, and the ricochet. And then lastly, this chip here is the one that is responsible for just the explosion sound. So now to test each of the sounds on this board, you take your probe. This is actually hooked to the white wire over here, as you can see. I'm using this because I have to touch each small pins, and it's easier with the probe. And we're going to focus down here on the J1 connector. And what we're going to do is we're going to take our probe and we're going to touch it to the remaining pins on J1. And if I touch J1 pin 5 with my probe that's connected to ground, I should get the gun sound. And that's pin 6, and that's the ricochet sound. So there's the gun sound, and there's the ricochet sound, pin 6. Pin 7 will give me the explosion sound. And lastly, pin 8 will give me the horse sound. Now if you touch these 4 pins and you get those 4 sounds, then that tells you that your 74154 decoder that's right here is working. But all you've done is you've tested 4 of the 15 sounds that this board is able to generate. And you want to make sure that all the sounds are working. To do that, you can do one of 2 things. You can try shorting combinations of the pins on the input connector, which this is a 4 to 16 decoder, so you have to short these in a binary combination. Or the easier thing to do, I find, is simply to short the outputs on the 74154. Usually, if you short these 4 pins and you get the correct 4 sounds out of the 4 pins on the input side of the 74154, that pretty much tells you that this chip is okay. It's rare where you would short one of these pins and get the correct sound and that it would not work in combination of pins that get shorted. I suppose it's possible, but it's highly, highly unlikely. So now to test the rest of the sounds, we're going to focus on the output side of the 74154. And basically, to generate each sound, we're going to short each pin on the output side. And we're going to start with pin 1, which is chime D. And that's the chime D sound. Now you'll notice that in here I actually have a 74 LS154. The original chip that was on this board was a 74 154. And when I did this, when I touched pin 1, I wasn't getting the D chime sound. So I removed the 74 154, and as soon as I unsoldered pin 1, you'll notice that it's broken off. My solder sucker soldered the pin right out. So it was broken, and this board was not generating the D chime sound. And as you can see, this chip is pretty roached. And there were also some bypass capacitors that were soldered directly to the pins on this chip. And what I did was I inserted a socket here, and I removed those bypass capacitors and I soldered them to the other side of the board. So all I had to do was pop a new chip in here. But right away, this test allowed me to find that I had a bad pin on this chip and it needed to be replaced. So now we can go and test the rest of the pins here. Pin 2 is the C chime. Pin 3 is the B chime. Pin 4 is the A chime. Pin 5 is the H chime. Pin 6 is the G chime. Pin 7 is the F chime. And now pin 8 will make the gun sound. And there's the gun sound. Now, to confirm that, if I go back to pin 5 on the input side, I should also get the gun sound. So as you can see, it's decoding, this is decoding properly the input to give me the right sound on the output. There's that gun sound. Now pin 9 is the snake sound. That's a rattlesnake. And pin 10 is the E chime. There's the E chime. Pin 11 and 12 on this side are now not outputs for the sounds. So we go over to pin 13, which is the horse sound. And again, if I go over to pin 8 on J1, I should get the same sound. So as you can see, that's correct. And pin 14 is the howl sound. Which is usually precedes the explosion sound in the game, but that's the howl sound. And pin 15 is the ricochet. And again, that's pin 6 on the input side, and so we'll test that again. As you see, so that's the same, pin 15. So that's the same sound. And then finally, the explosion sound is pin 16. And if I hit pin 7, I should get the explosion sound on the input. So that's it. We've now tested the speaker and the output. I can adjust the volume too, by the way. Just crank this up, and if I hit the explosion, so my volume adjust is working. I'll turn that back down now. So we have our output, our amps, our speaker. That's all been tested. The input side, the 74, 154, and then we've gotten all of our chime sounds from the C chip. This one, all the chime sounds, all of our sound effect sounds from the B chip, and the explosion sound from the A chip. And next we're going to do an SSU-3.